Hello, welcome to Completing the Square in Circle Equations Part 1. This is Mr. Giovanelli with Agua Fria High School Distance Learning. All right, here's our new essential question. You can write this down on top of your notes. When and how do we complete the square to find the center and the radius of a circle? So we're going to be using a skill called completing the square, which is also in the standard, you can see here, that you probably will recognize from Algebra 1. I know if you're currently in Algebra 1, you've already learned it. If you had it last year, you definitely learned it. So here, again, I want to remind you, use Desmos. Desmos, again, is going to be a huge resource for us as we move through this material. All right, let's begin with a little recap of what we talked about yesterday. So a circle is given by this equation, and if we want the center and the radius, this is not the format that we can easily use to pick out the center. The radius may be not so hard to pick out right now, but we can't pick out the center. We want it to look like this. X minus h squared plus y minus k squared equals r squared, right? So we need to change these little sections. We need to factor them to see if we can get it into the format that we want. So let's think about, we need a number, a single number that multiplies to positive 16 and adds to negative 8. What's that number going to be? That's going to be negative 4. And I'm really going to kind of draw this out this time. If you do negative 4 times negative 4, you'll get positive 16. Negative 4 plus negative 4 is negative 8. So this equation factors to this, x minus 4 squared. That's the format we want. Similarly, over here, if we kind of continue our work, I'm looking now for a number that multiplies to 81 and then adds to 18. And we're looking for the same number here. So this time it's going to be y, that should have been a y. Whoops. It's going to be y plus 9 times y plus 9. All right, and then we didn't do anything to the 32, so we're leaving the 32 alone. And then if we put it all together, this becomes y plus 9 squared. This becomes 32. All right, so our center now we can pick out much more easily. Flip the signs, positive 4, negative 9. And then our radius is going to be the square root of 32. And of course, we could simplify that if we wanted to into the square root of 16 times the square root of 2. Whoops, that's supposed to be a 6, which is 4 square root of 2 if we wanted it in simplified form. All right. I encourage you, as always, to use Desmos to check your work. Okay, so this is me. Just all I did is plug in the original formula we were given here. And you could probably pick out the center just from this. Not so easy to pick out the radius if the radius is not a perfect even number, but you could see that the center is at 4, negative 9. I just think I like to plug in both because you're going to see that your answer is correct. You can kind of flip back and forth by turning one of them on, one of them off, and you can see that your answer is correct because you've turned it into the correct form when you started with this form. All right, now let's get to the topic we are learning today, which is finding the center and the radius by completing the square. So first of all, let's talk about how do we know we're supposed to do this? Well, one good indication is that you're going to see that you only see 2 terms here instead of 3. So to be able to factor this, I need to have 3 terms, unless I just want to factor an x out, which I don't. I want to get a perfect square term to put it in the format where we can easily pick out the center. So I need to add something to this. I need to do something called completing the square. And the way you complete the square is by adding the b value divided by 2 squared. That's going to give us a perfect square down here. So let's do that. The b value is whatever number here is in front of your single power term. So I'm going to add 4 divided by 2 squared. Then let's do this to the y term as well. So here, our b value is negative 12 now. So I'm going to add negative 12 over 2 squared. All right, and it's still all going to equal 41 because I haven't touched the 41. But since I added to the left side of the equation, I also need to add to the right side of the equation. So I'm going to add this term to the other side, and then I'm going to add this term to the other side. All right. Okay, let's see what happens. We got a bunch of fractions and squares, and you'll see that it'll get a lot less complicated in a moment once we start simplifying. So here we have x squared plus 4x. Now 4 over 2 is just 2. So this is actually just 2 squared, which is 4. And then moving on to the y terms, negative 12 over 2 is negative 6, but if you square that, you're going to get positive 36. So what we really added to the other side, what we really added was 4 and 36 after we simplify those fractions. Okay, because we're squaring, one little tip, these numbers should always turn positive. Even if they started negative like that 12 did, they'll always turn positive. Okay, now watch what happens. Something always will happen if we do this right. These have now become perfect square trinomials, so I can factor them into binomials. So this expression here is actually now x plus 2 squared. And then this expression here, I need two numbers that multiply to 36, add to negative 12, so that's going to be negative 6. And then all I have to do is sum these numbers up. So 45 plus 36, that's going to give me 81, right? Yeah, 45 plus 36. Okay, now this you should recognize from yesterday's lesson now. So our center is, flip the signs, negative 2, 6. And then our radius is the square root of 81, which is 9. Okay, just a quick recap because I know that was a lot of math on one page. To complete the square, you have to do this twice sometimes to make the x and the y terms factorable if they're not already. And to do that, you're adding b over 2 squared to both sides of the equation. Okay, and the reason we call this completing the square is because you are literally adding a value that will make any trinomial a perfect square. All right, let's do one more so we can kind of see how this works one more time. And I'll kind of like do it all in one move so you can kind of see it from the big picture. So first thing I'm looking at here, I'm trying to find the center and the radius again of this circle. I'm noticing that x squared minus 20x, I don't see a third term. I don't see any way I can factor this without completing the square. So I'm going to make this a perfect square. So I'm just going to leave a little blank there because I know I'm going to have to add something. So I'm going to do y squared plus 6y. Okay, I'm noticing the same problem. I don't have any way to factor this, so I'm going to have to add something, so I'll leave another blank, equals 35. Okay, negative b over 2 squared is what I'm going to add. Remember, I'm adding b over 2 squared. So my b value here is negative 20 over 2 squared, and my b value here is 6, so 6 over 2 squared. All right, and I got to remember that I'm going to end up adding these to both sides of the equation. So negative 20 over 2 squared plus 6 over 2 squared. All right, here we go. So x squared minus 20x. Half of negative 20 is 10. So square that, that's 100. Plus y squared plus 6y. Half of 6 is 3. Square that, that's 9. All right, so what I actually added to 35 over here is I added 100 and I added 9. All right, now things will become more clear for us. So remember, if you do this right, you're always going to get a perfect square binomial. So x minus 10 squared will be the factored form of this because negative 10 times negative 10 is 100, negative 10 plus negative 10 is negative 20. And then over here, we're going to have y plus 3 squared, again, because 3 times 3 is 9, 3 plus 3 is 6, and then I just have to sum up what's on the right, 35 plus 100 plus 9, that's going to be 144. All right, from here now I can get my answer. My center is going to be at 10, negative 3, flipping the signs, and my radius is going to be the square root of 144, which happens to be a perfect square, which is 12. All right, last problem we're going to do here, we're again finding the center and the radius, but I want to show you how to work with one where there's some fractions involved and also our b values are odd numbers, which you're going to see will make our math a little more advanced, but nothing you can't handle. All right, so here we go. We know we're going to complete the square again, so I'm just going to leave blanks where we're going to add our value to complete the square. And the value we're going to add is, again, the b over 2 value. So here it's going to be negative 3 over 2 squared plus negative 5 over 2 squared. And got to make sure I do that to both sides of my equation. All right, and let's just keep everything as a fraction, not worry about changing it. So this is going to actually become, square the top and the bottom, going to become 9 over 4. And this is going to become 25 over 4. All right, so I can rewrite that as plus 9 over 4 plus 25 over 4. All right, let me clean that up a little bit. All right, and now let's factor out the bottom. So let's take care of the completing the square part first. So what you're going to notice is something that's kind of interesting. The number you want, the perfect square binomial number, you actually have already found. It's actually right here. So I want x minus 3 over 2 squared. That's going to give me negative 3 over 2 squared is going to give me 9 over 4. And then negative 3 over 2 plus negative 3 over 2 is going to give me negative 3. This is basically just another way to say negative 1.5. And the same thing works on the other side. What I want here is y minus 5 over 2 squared. Again, for the same reason, negative 5 squared is 25 over 2 is 4. And then negative 5 over 2 is like 2.5. So if you double that, you would get 5. Okay, now let's deal with the right side of the equation here where you notice we have an uncommon denominator. So let's do this. Let's double this on the top and the bottom. So it becomes 38 over 4. So now we have common denominators all the way around. All right. So everything's over 4, so we can just add everything. Okay, I don't have anything to do to change this. This is ready to go. I can actually see the center right now. But to get to our radius, let's simplify the right side. So add the tops, leave the bottoms alone. 38 plus 9 is 47 plus 25. That's going to give us 72 over 4. All right, and if we divide 72 by 4, that's going to give us 18. So we can now say our final answer here, which is our center is positive 3 over 2, positive 5 over 2, or 1.5, 2.5. And then our radius is the square root of 18, which can also be thought of as 3 times the square root of 2. All right, that's it for today. Check in with me at the Q&A if you need some help. You're now ready for your exit ticket. Keep it up.